So next, I would like to introduce our next speaker, Keith Strier. Keith is, to give you an interesting, different perspective of AI from another point of view. So Keith is Senior Vice President, Global AI Markets at AMD, responsible for expanding the company's strategic vision for AI, driving new ecosystem capabilities, and accelerating strategic AI engagements globally across public and private sectors. Previously, Keith was Vice President Worldwide AI Initiatives at Nvidia, where he built Nvidia's global portfolio of AI nations partnerships and sovereign AI businesses. Keith has 30 years of global leadership experience, having served as the first global AI leader at EY and the first global chief digital officer at Deloitte. He holds multiple AI policy leadership appointments worldwide, including founding member of the US National AI Advisory Committee, International Working Group at the US Department of Commerce, founding co-chair of AI Compute and Climate Expert Group at the OECD, where he led the development of the first blueprint for building domestic compute capacity. He's also a member of Australia's National AI Centre think tank and founding co-chair of the Commonwealth AI Consortium, which harnesses AI to support the most climate-vulnerable small states. Clearly, he's an underachiever. Yeah. Truly amazing background. So Keith holds a bachelor's degree with honors in industrial and labor relationships from Cornell University and a JD from the New York University School of Law. We're very lucky to have Keith come here and talk to us. Keith.
Thank you, sir. That's great. Thank you.
There you are.
My water over here. Good morning. It's great to see everyone. Thank you, Aparna. I don't know if you're still here, but that was a brilliant presentation. There is a little overlap between our presentations, but just a little bit in a good way. Aparna is clearly a brilliant engineer and has a very deep technical background. I am the non-engineer AI keynote. So I'm going to come at it from a slightly different angle, although there's a little bit of overlap in content, but it's actually fun. So first, one little aside on visuals. So I was creating my opening image for today, and I go to all the different image options. You go to Grok and ChatGPT and Gemini, trying to figure which one makes the best image for you. And I had coined this term, the great AI gear shift, which I thought was kind of fun. And so I tried to create an image to go with it. The first image I created was a picture of the Earth with these gears kind of smashing through them and robots coming out of the fissures in the Earth. I thought it looked amazing. I shared it with my PR team, and they just said, no. They killed that. So I came back with this more pleasant-looking thing with gears and light bursting through it. So anyway, obviously you can create whatever image you want. I didn't want to make it scary, but I just thought the first one was a little more fun. So the other thing, the one thing that Aparna did, which I really loved in the beginning, and I'm going to do it too, is tell a personal story. Because when my friend Achin asked me to come do this keynote, I thought to myself, all right, well, I have to try to connect with the audience, right? It's important when you speak to try to connect with the audience. There's really two primary ways you can do that. One is humor, and I got to tell you, display technology humor is hard to find. I mean, maybe you can send me some links after. I really struggled with that, so I kind of put that one aside. The other way you can connect is through a personal story that actually has some shared experience or shared perspective. And then I had this aha moment. I actually have a great personal story that'll really bond us together around display technologies. Believe it or not, I have a genuine family history in this field. So let's take a look at this picture. Now, I just grabbed this picture from the internet. I don't know who that is, and I don't know where that is. But that image is very similar to some childhood images I have, because that guy could very well be my grandfather, Bernard Guth, who from 1940 to 1980 owned a TV store in Lower Manhattan at the east side, right off of South Street Seaport on Fulton Street. For 40 years, he was the local TV guy. And if you were buying a TV in the 40s or the 50s, this is where you went to get a television. It looked just like that. I mean, I have pictures of that in my mind. These rows of televisions, and you go pick out your favorite RCA or Zenith or whatever it was, right? You had these great televisions. And my grandfather, Bernie, he was actually a really good salesman, so good that he and my grandmother, they got to go all around the world in these junkets. They got to go to Japan and Italy, all courtesy of his great sales skills. So he had this store, and of course, if you go back to these TVs, right? These TVs, do you remember what powered these TVs, right? Vacuum tubes, right? This is right, the original technology, right? The cathode ray tube. I mean, you think about this incredible technology, and many people contributed to that field, and German physicist Ferdinand Braun, he created that Braun tube, which was really one of the pioneering sort of early TVs that led to what we have. But these TVs were clunky. They were actually hard to maintain. These vacuum tubes broke all the time, and these TVs are big and heavy. So what was, at that period of time, if your TV broke, you'd either call a TV repairman, that was one thing you could do, or if you were industrious, you'd buy a book, and it would be like how to fix your own TV, right? And this was a thing. This was a very popular thing to do, and you'd go and you'd look up exactly what kind of tube broke, and you'd go buy at the store, often for someone like my grandfather. And as it turns out, not only did my grandfather sell TVs and fix them, because that was, if you sold them, you'd typically fix them too, but he was also a best-selling author. And he wrote a book on how to repair your TV. And actually, I have that book right here. I actually have it. So this one he published in 1951, and this was 1959. It's actually pretty, you could actually buy this on eBay. It's a collector's item. I didn't buy it on eBay. I have the original, but you can actually go on eBay and buy these. And it's actually just fascinating to look through these, the detail of, which tube, anyway. So I just thought I would share the fact that if Bernie were alive today, and he's not, but if he were looking down, he would be smiling and super happy that his grandson is on this stage speaking to you in the display technology. And I think that's kind of cool. So it took about 75 years, right, to go from CRTs, right, these cathode ray tubes, to LEDs. 75 years. And that number, 50, 75 years, that's a pretty common pattern in the technology world, right? It took only about 70 years to go from the first flight in human history to the moon, right? And so we have all of these leaps. And Aparna had a timeline on screen, and I'm going to have one too. Mine's a lot harder to read though. But the bottom line is there are all of these timelines, all of these technology timelines. And if you go back in history, you have these leaps that take hundreds of years, and then they take 100 years, and then they take dozens of years, right? So you do see a pattern here, right, where technology is accelerating. And it's accelerating for some very clear reasons. It's accelerating because the technologies are converging. And as they converge, it makes it easier for ideas to scale, to be adopted, to be tested, even to fail, right, and to iterate and improve the next generation. But these innovation cycles, they're happening much, much faster than ever before. And of course, the technologies build on top of one another, right? And so you start to see what used to take 100 years, then takes 50 years, then takes 10 years, and in some cases now takes weeks or days. It's actually quite hard to keep up. I'm an executive now in the semiconductor industry. I was vice president of Nvidia, and now I'm senior vice president at AMD. And it used to be that you'd roll out a chip every 2 years, and even that was hard, right? I mean, the amount of time it took to design and engineer and tape out that new chip is, and the billions you had to pour into that R&D and then ultimately the manufacturing process. I mean, you needed 2 years. You probably wanted 3, but you had to make it happen in 2. Now, because of the speed of innovation, because it's not possible to wait 2 years, we have to do it every single year, right? Just like Apple introduces a new phone every year, we have to introduce a new processor every 12 months. That is mind-blowingly hard, right? The amount of innovation in engineering and manufacturing, the supply chain does not move that fast. So you have to really make these decisions years in advance. You have to make these incredible bets, right? So this is part of the time scale of technology innovation. Now, we're here to talk about AI for the next 17 minutes. So Aparna did a great job getting into a little bit more of the technical aspect of where things are going and how amazing the progress has been. But I want to tell that same story a little bit of a wider lens, right? I want to give you a little bit of technology history, but also some geopolitical insight, and also just think about, and of course I'll eventually tie it back to display technologies, but I want to give you kind of this big picture. So 2012 was a very important year, and we're going to look at the 10 years ahead of that, 2012 to 2022. 2012 was very important, not because things were invented that year, but this is the perfect example of convergence. Now, these three boxes, you got ImageNet on the left, which is really the world's first large-scale database of labeled images. It doesn't sound that interesting, but actually it was an absolute breakthrough pioneered by Fei Li, who was one of the preeminent AI pioneers at Stanford. And she started doing that, I think, around 2007. But by 2012, her database finally was applied to create something called AlexNet, which is on the right. And AlexNet also wasn't invented in 2012. It was reflecting years of data science research and work by all these brilliant people, some of whom have now won Nobel Prizes. But it was the first successful implementation of this new idea called deep learning, right? And all of that was only really possible because of the thing in the middle, which is the GPU, right? The graphical processing unit, which is this specialized processor. And it's really hardware and software, but it's this specialized processor that used the benefits of parallel processing to truly accelerate math. And ultimately, AI is just math, right? So when you converge these three things together, when they all got applied together, this incredible labeled image database with this incredible computing platform, with this incredibly new complex architecture called deep learning, boom. That's what happened. You might not have heard it, but that's actually what happened. Boom. 2012 was the beginning of the modern era of AI. And as was referenced earlier, AI has gone like this. We've had winters and summers, but this was the beginning. Everything you're seeing today started with this convergence in 2012. Now, within just a few years, again, because now you see decades, potentially 100 years of progress happening in very short periods of time, right? Like, we're talking time machine potential here. So now, just a few years later, Google goes to South Korea. Now, I didn't grow up playing Go. I grew up playing chess. But I imagine, some of you grew up playing Go? Is that a thing? Any hands raised here? I'm just curious. Yeah. So this is an incredibly complex game, right? This is like chess. It's an abstract strategy board game. But unlike chess, it's completely unsolvable, and it's infinitely more complex. There's as many moves in Go as there are stars in the universe. You really can't brute math your way through it like you can with chess. It requires deception and cunning and strategy. It's a very, very complex game. And when Google showed up to compete with Lee Sedol, who at the time was the most celebrated Go player alive, nobody believed that they were going to win. Nobody. They did a survey of data scientists, of top data scientists at the time. Said, do you think Google has a shot? And they all said, no, maybe in 5 years, maybe in 10 years, right? So this was a very, very unexpected event. And when Lee Sedol lost, it didn't just send a shockwave through the tech sector. In fact, I would argue it may not have sent a shockwave. Other things did. It sent a shockwave through governments. Because not only was that an AI beat a human, that's one narrative. The other narrative is that it was a US-made AI that beat a South Korean brilliant Go player. And that message resonated all across Asia, and in particular in Beijing. And only a short while after this game, China announced that it was going to become the world leader in AI. This was the alarm bell that woke up Asia to the critical importance of AI as a geopolitical lever. So this was a very, very important event for many different reasons. But of course, it also signaled the fact that this technology was perhaps getting better faster than we expected. So just 1 year later, we're already showing evidence of algorithms that are able to diagnose human disease more accurately than humans, right? You can use computer vision, you can look at an X-ray, and actually a human radiologist would be less effective than an AI at this task. And this has been proven out now in a number of modalities. This is not, I mean, now we're about several years later from this. There's a long list of clinical diagnostic domains in which AI is actually more accurate than humans. So this is, but this started to show up in 2017, right? These are serious things. We're not talking about games now. We're talking about human lives, right? But there was another narrative that also emerged at this time. And that's the narrative around risks and issues unrelated to efficacy, which is that when you build these tools, you have to design them well. You have to design them responsibly. That actually, they may be appearing to work. Like traditional technology, if you turn it on, if you go turn on the television and it just works, well, it's great, it works. You only really get concerns when it doesn't work, or you have static, or the speakers don't work, or maybe there's some disruption to the screen. But by and large, it either works or doesn't work. That's not true with AI. AI can appear to be working perfectly. It can be providing an output very confidently, giving you a steady stream of information and answers. But what you don't know is that beneath the surface, that data is biased. The results are biased. It's not actually a good result, but that's not obvious if you don't know to look for it. So what we learned starting around this period of time, as AI started to move into sort of, we'll call it the POC stage, right? As people started to test and the most advanced companies like in Amazon were figuring out how to apply AI in their business, they discovered that it's actually not as simple as it sounds. That you can build these models, but can you rely on them? They produce an output, but is that output something you should make a decision based on? What Amazon found is they built this tool to support their recruiting process, is that it sorted through resumes perfectly, but it sorted through them with a deep bias against women. And they acknowledged that it was not actually recommending any women for technical roles. It was only recommending men. So they took the system offline, and to their credit, they acknowledged this problem, which I think helped bring awareness to the fact that you have to design these systems very mindful of the risks. And this is, to this day, the idea of AI safety and so forth is a very key theme for global AI governance. And that brings us to 2022. 10 years, right? I love this quote from Aaron Levy. I think it's a really great quote. ChatGPT is one of those rare moments in technology where you feel like you see a glimmer how everything is going to change. I was very fortunate to have been right there, kind of in the front row, in real time as this was unfolding. ChatGPT hit right around the last week in November. About 10 days later, I happened to be in Europe, in the Gran Canaria Islands, at a very special meeting called the OEC Digital Ministerial. Basically, every 5 years, all the digital ministers of Europe get together and talk about the future of Europe. And so these are the key leaders driving the digital agenda for Europe. And so I happened to be at that meeting, again, shortly after ChatGPT dropped. And the truth is, in the US, it was still not the phenomenon yet. It hadn't actually, the boom hadn't happened yet. But here I am on this island off the coast of Africa with Europe's digital leaders, and I got to tell you, it's all they wanted to talk about was ChatGPT. It was the primary focus of every single meeting for 3 straight days. So I came back for that meeting, and it occurred to me that this is a much bigger event than we thought it was. It was probably another month before we really processed ChatGPT and its impact on the world. And by February of 2023, ChatGPT had become the fastest adopted technology in the history of mankind. 100 million users within 60 days. That has never happened. I mean, if you look at other things, Instagram, YouTube, just go down the list, right? I mean, it took years what ChatGPT achieved in 60 days. And it did that in part because of what I talked about earlier, this incredible convergence of technologies that lets us obviously absorb and test these things. But it was also because it blew the hinges off of the door on our expectations on what AI could be. We've all spoken to things that we thought were going to be like AI or some kind of computer program that said you could talk to it or converse with it, but this was different. This actually spoke in a very natural language, and you can go in any direction. You could actually have a conversation, and it started to feel very much like a synthetic human being. So ChatGPT achieved its goal. It wasn't perfect by any stretch. In fact, it was a deeply flawed technology in many ways, and not a very reliable technology and subject to hallucinations and all these things. But that doesn't change the fact that your first impression was the strongest realization to date that what is now possible is that we are approaching the era of artificial general intelligence or artificial superintelligence, all these things. So 10 years from the very first example of deep learning architecture being applied to ChatGPT, right? That's all it takes. And now, because that's now 2.5 years ago, right? Just about. So now things are just happening super fast. I mean, Aparna joked on the stage how they may have dropped a new model today, because that's what's happening. We're moving at a step. We're moving at a pace that I think is hard to completely explain. When I talk to prime ministers or crown princes and other world leaders about this, and I have private meetings all the time, and they say, well, how do we stay ahead of this? I said, there's absolutely no way to stay ahead of this. You can't stay ahead. You got to get in it, but you can't stay ahead of it. You have to know it's happening. You have to believe it's happening. You can't deny that it's happening, but you cannot get ahead of it. So it's just a fact. And I actually like to think about the world very simply as pre-ChatGPT and post-ChatGPT. Like, to me, it's a very clear line of demarcation. And what happened after ChatGPT is this. There's a new race. Now, there's a lot of dimensions to this race, but I'm just going to talk about 3 because, we don't have 2 more hours. So here's the 3 dimensions I'm going to talk about. Sovereign AI infrastructure, that is the pursuit for AI independence by nations. Artificial superintelligence, or the pursuit for AI benevolence, could also be referred to as AI supremacy. Pick your favorite term, but this is where we're headed. And then humanoids, really the idea of sort of both digital and physical labor, non-human labor, and how that's going to affect the future of work and markets. So since 2017, countries have been pursuing national AI plans. So this is not a new thing. I was actually one of the first advisors to countries on this topic. I helped several countries in Europe write their national AI strategy back in 2018 and 19. So this is not a new thing, but now it's accelerating. All the countries in the world, well, that's not entirely true. 192 countries, I would say roughly 120 of them have national AI strategies. So not every country in the world, but nearly all. And it affects everything from their policies to diplomacy, to national security, to culture. I mean, this is a very complex conversation. It's not just about technology. If you're looking at your phone today, and I know some of you, because I actually walked by and I noticed that you saw pictures of President Trump is in Riyadh right now, literally right now, and he's surrounded by US tech CEOs, including my own CEO, Lisa Su, right next to him, on stage, talking about the future, not only of the relationship between Saudi Arabia and the United States, but specifically this topic, specifically investments. And you'll see headlines. Saudi is announcing billions, trillions of dollars investment in US technology companies, including AMD, to help them build their sovereignty, preserve their sovereignty, and to grow their AI infrastructure. That's a big deal. This is the new basis for competition, and it is for you too. It is for you in the display technology industry, right? Increasingly, everything will be generated. Aparna kind of hinted at this at the end when she talked about the UI being generated, right? Everything will be generated. Music, pixels, movies, ideas, everything will be generative in nature going forward. So when you think about everything can be generated through AI, how does that change your industry? And it does in a very material way, but this is true about the future of competitiveness in general. This is not obviously a narrow statement about your sector. But to be optimistic about it, and we've referred to Fei earlier, she was the one that created that ImageNet database I mentioned. AI is not supposed to be a substitute for human intelligence. It's really supposed to amplify human creativity. It's supposed to make us better. And it is ultimately a tool, right? It's not so much, people worry about AI, and there's a lot of very important people that fear AI, but it's not AI you should fear, it's people, right? It's people with AI. Ultimately, it is just software. And we decide how it's designed, we decide how it's applied, we decide where it goes. For the most part, this tool should be able to save us. And if you think about it, artificial superintelligence, which means intelligence that exceeds human capabilities. That's what it means, superintelligence. But it should be able to help us solve our greatest challenges, right? Curing disease and climate change and predicting extreme weather events. I mean, do you know how many people die from floods on an annual basis? That's the number one most extreme event is flooding. And flooding is entirely predictable. It just is. It's a combination of data on urban design and data from satellites, geospatial data, plus data from other sources. When you combine them and you predict things, you can predict not just the event of a flood, but the flow of the flood and the expanse of the flood and the depth of a flood. You can get ahead of these conditions, and then you can mitigate disasters. But you can only do it if you have the data and you have the AI, and increasingly if you can visualize it in a way that's actually compelling and changes decisions and compels people to take action. But all the mysteries of the world, from cancer to quantum physics, will be unlocked with AI and humans working together. This is the future we're in. So now that's purely on the digital side, but let's not forget that adjacent to that, there's also a lot going on the hardware side, the physical side. Now again, we like this number 10 years, so let's stick with it. 2008 to 2018, the rise of cobots, collaborative robotics. The idea that you're going to put a machine right next to a human, not in a cage, not on the other side of the building, but right next to a human, and they will work together. Now, the first generation of cobots, and that's literally the first one, the UR5, was sold 10 years in 2008. Not a very smart machine. For the most part, it's just following rules. It kind of takes commands and then it follows those commands. It has a sort of a pattern, and it just sort of repeats that pattern, and you know, if this, then that kind of thing. No AI involved, right? But still very effective, still very useful, still complementing human labor. Now, you know, we're well over 500 million to $1 billion in sales just for this one machine, and it's not even very smart. Of course, where we are today is called agentic AI. This is where AI goes beyond just being a question and answer tool, a chatbot, to something that you assign work to. You give it agency. That's why they call it agentic AI. When we talk about agents, they're really talking about AI models that are so advanced and have been empowered by you as a human that they could take actions on your behalf. They could not just ask a question like, how much does it cost to fly from Miami to LA? You can go further than that. You can say, find me the best flight at this time and buy me the ticket. Book the ticket, and I want a window seat, right? This is going beyond asking a question and assigning a task. This is what agents are about. And obviously, we're not talking about just buying plane tickets. We're talking about PhD-level AI agents that have human-level cognitive abilities to do very complex scientific work or financial work or all sorts of work. And you can assign them to do things, and they will coexist. In fact, if you're a CEO today in this room, you are the last generation of CEOs who will only have humans as employees. No, I didn't say last generation of CEOs. I didn't say that. You laughed too soon. Last generation of CEOs with human-only workforces. All future CEOs will preside over a hybrid workforce that will include AI and humans. That's just the way it's going to be. Now, when you take this level of AI and you combine it into a machine, you get this. And this is where we are. This is happening very, very fast, right? This is C-3PO, right? This is Star Wars. It's happening at scale. I have been in labs talking to humanoid robots while they're walking around. It is mind-blowing. It's happening faster than you can imagine. China is way out in front on the mechanical part, and the West is way out in front on the AI part, and they're kind of coming together. And so within just a few years, not double-digit years, 3, 4, 5 years, we will have large-scale production of humanoid robots. This is going to be part of your future. Your children and your grandchildren will not know a world that does not include these, right? So now you've got all of these things coming together, right? This is the new dynamics, because I'm out of time. I got to wrap it up. This is the new dynamics of an AI world, right? We've got new types of industries. We've got new types of innovation, new forms of expression, new ways to share, to promote, to consume. I mean, all of these things are possible. New types of user interfaces, new ways to anticipate and predict what people want, but also to deliver it to them and to engage with them. So all these things are possible with AI. Because basically what you're doing is you're taking human-like cognitive abilities to see, to understand, to empathize, to communicate, to engage, to act, and you are able to simulate and scale it now in a digital way. So now converging that with this amazing conference that my grandfather is very proud that I'm here. You think about all the different ways you can leverage this in your business. Accelerated development cycles, your ability to not just put AI into a TV, but rather use AI as a co-pilot in the design process to accelerate design, right? To shorten those innovation cycles, to generate the next kind of display technology may not come strictly from some brilliant human being, but some brilliant human beings using AI to accelerate their own thinking, right? Creating new kinds of interaction paradigms that Aparna talked about, hyper-adaptive displays, the ability to use essentially computer vision and other kinds of AI sensors, but then applying these human cognitive level skills within the machine. I don't even think we can completely fathom what that means, right? But it's possible. Advanced content creation, right? Essentially, you can generate not just hyper-personalized, but an experience just for you, based on you at that moment. So the content generation part is pretty straightforward. Groundbreaking visualization capabilities, right? Combining all the brilliant engineering in this room with the infinite possibilities of AI will unlock a whole new chapter for display technologies, and ultimately revolutionizing marketing, communications, obviously medical imaging, all the above, right? There's no limit. So I'm very excited for it. I can't wait to come back a year from now and to see all the ways that AI has transformed the world and transformed your industry. And I hope that was a good use of the last 30 minutes of your time. So let me give the stage back and thank you very much for letting me be here.